Lately, when I go onto social media, especially Facebook, I'm seeing an increasing number of attacks on public education and, in particular, Common Core, which is hilarious because most states have abandoned or revamped Common Core into their own state specific set of learning standards, which includes New York State. In 2017, New York State adopted the Next Generation Learning Standards. So if you hear anyone complaining about quote unquote Common Core as some kind of Marxist liberal takeover of American education, you know right off the bat they're talking out their ass. In fact, if you asked one of these people, what Common Core is or what their problem is with it, they probably couldn't tell you. I doubt they even know what Common Core is, except for their perception of this. Math problems being done in strange, roundabout, and seemingly nonsensical ways, at least on the surface, if you take fewer than 5 seconds to examine what's going on. So I want to take a look at two seemingly famous examples of parents who have virally shared their students' homework to, shame their teachers, shame the American public education system, and show how much smarter they are than anyone in education. So let's start with this first one. It says, Jack used the number line below to solve 427 minus 316. Find his error. Then write a letter to Jack telling him what he did right and what he should do to fix his mistake. So 427 minus 316, and he used some kind of weird-looking line with bumps on it, and he's writing all kinds of different numbers. And I think what the worksheet is representing is that he made his way down here to 121 is the typed answer, which is wrong. And then you can see where I guess it was the parent who filled in this worksheet angrily. They added some of their own numbers. But the parent wrote down here the kind of traditional way of subtracting, the up and down method. I'm sure there's a better name for it, but 111 is what Jack should have arrived at, but he got 121. So the parent wrote to Jack, Dear Jack, don't feel bad. I have a Bachelor of Science degree in electronics engineering, which included extensive study in differential equations and other higher math applications. Even I cannot explain the Common Core mathematics approach, nor get the correct answer. In the real world, simplification is valued over complication. Therefore, 427 minus 316 equals 111. The answer is solved in under 5 seconds, 111. The process used is ridiculous and would result in termination if used. Sincerely, frustrated parent. So, first off, if you're using your degree to validate your intelligence, you're probably not that smart. I have a master's degree and I'm a damn moron. Degrees mean nothing. Nobody's impressed with your Bachelor of Science degree in electronics engineering. Although I am skeptical of if you are doing extensive study in differential equations and you can't figure this out, something's wrong. Either you don't have that degree you're bragging about, or I don't know, you have brain damage. Because I looked at this and in about 5 seconds, I figured out what was going on. I will remind you, I am not a math teacher. I have spent lots of time in public schools, so I'm sure I've absorbed some things from other teachers who do math in their classroom. But again, I'm not an expert at this, and I figured it out. So Jack was just using a number line to solve this problem. Number lines are a tried and true strategy for students who have perhaps math-related learning disabilities, such as dyscalculia, or for students who don't have learning disabilities but just kind of suck at math, like I always have. So he started at 427. He knew he was subtracting 316. So he started off by skip counting by 100. He took off 300s. So 100, 200, 300, got him down to 127. Then it looks like he made 1, 2, 3, 4, 5, 6 more little jumps and arrived at 121. Again, that's what's typed on the worksheet. That is Jack's answer, 121. So what did he do wrong? Well, he forgot the tens place, didn't he? He went right from the hundreds place to the ones place, and that brought him down from 127 to 121. If he had remembered to make one jump in the tens place before that, then his answer would be 10 lower, and he would have arrived at 111. Now, it looks like the parent did not pick up on this. They sort of underlined all these numbers, and then they thought that Jack's mistake was that he counted 6 tens places and got down to 57, but that's not what happened. He counted 6 ones places and got down to 121. Like, how do you not see that? Again, this number line strategy is not Common Core. It's not new. It's something that has been around for a long time, and it's a tried and true strategy for, again, anyone who just struggles with math, or maybe they have a learning disability. This is a perfectly fine way to do it. Now, are you always going to do it this way? No, of course not. And in fact, you're not always going to do it the traditional way either. Once you have a grasp of arithmetic, you're just going to use a calculator. I like how the parent said that this would result in termination if used. So I imagine he's like some sort of mid-level manager at his job. I don't know. I just can't understand why he would want to fire someone for not being that good at math. We'll get back to that idea in just a minute. Let's take a look at the learning standards addressed by this problem. If we go to the New York State Learning Standards, it says fluently add and subtract within 1,000 using strategies and algorithms based on place value, properties of operations, and or the relationship between addition and subtraction. But the important part is fluently adding and subtracting within 1,000 using strategies and algorithms based on place value. By the way, I don't know for sure that this math problem came from New York State, but I'm using the New York State Learning Standards. I don't know for sure that it was a grade 3 math problem, but the grade 3 standards most closely matched that example problem. So that's what I'm going with. And I know you're probably saying, though, well, you can't use the standards to justify the standards just because the standards say adding and subtracting within 1,000 using different algorithms. Well, I mean, that's like using the Bible to prove the Bible. Well, I challenge you to look at any of these standards and tell me which one of them should students not be learning, or which one of these is nonsensical. Look at 4A. Understand that the digits of a 4-digit number represent amounts of thousands, hundreds, tens, and ones. Does that sound like some kind of hippy-dippy Marxist takeover of math education? It sounds like pretty standard math stuff to me. I like the note, too. Students should be taught to use strategies and algorithms based on place value, properties of operations, and the relationship between addition and subtraction. However, when solving any problem, students can choose any strategy. Note, a range of algorithms may be used. That means you can use the traditional up and down setup there. You can use the number line, or probably some other strategy I'm not aware of. Let's look at number 2. Another sort of virally circulated Common Core math problem. You can see that and again, this one, as far as I can tell, probably matches up most closely with 3rd grade math. I don't know if it's from New York State, but based on what I'm looking at in the New York State math standards, this is probably a 3rd grade problem. That's what I'm going with. So it's 312 times 23 equals X. And yeah, weird way of doing it. They got the right answer, 7,176, but oh, what a weird, stupid way of doing it. Boy, the liberals and their pronouns are just ruining math education. I mean, they can't even decide on a gender, am I right? Well, the parent wrote down here, they showed their kid kind of the traditional way of doing multiplication by stacking up the numbers and yada, yada, yada. After being homeschooled by a quote-unquote essential employee, hashtag I don't have time to learn new things. All right, first of all, I don't know what the quotation marks signify. I'm guessing this is just a person who doesn't write a lot, and people who don't write a lot and are kind of uncomfortable and tentative with written language, for some reason tend to use a lot of unnecessary quotation marks. I'm guessing that's what that means. I don't think it means anything beyond that. Also, hashtag I don't have time to learn new things. I'm wondering how this person would do in a job interview with the frustrated parent who would terminate people if they did things the wrong way. I don't agree with either of these people, obviously, but if I were a hiring manager and someone proudly stated to me, I don't have time to learn new things, and said, I only like to do things the way they've always been done. I'm uncomfortable with change. I don't like finding new ways of doing things. I'm very inflexible. I probably would not want to hire that person. That does not sound like an employee I want to have. Anyways, getting back to the math problem. If you spend under 5 seconds looking at it, this could seem really obtuse and stupid. But again, it's just another strategy. Well, it's not even really a strategy. It's just, as far as I can tell, more a way of visualizing multiplication. And again, emphasizing place value. So they broke it down. They broke down each number in the problem into its component place value. So 300, 10, and 2 represents that number. And 20 and 3 represent that number. And then they're just kind of multiplying each one together in their boxes. So 300 times 20, 10 times 20, 2 times 20, 300 times 3, 10 times 3, 2 times 3. Then you just take all the products of those smaller, easier mental math problems, tally them up, and when you add up all those things, it comes out to 7,176. Now, of course, once you have mastered multiplication, you're not expected to do it this way. In fact, you're probably not expected to do it this way consistently on your way to mastery. It's just a way of conceptualizing it, seeing why 312 times 23 equals 7,176. It helps you visualize it better and see how multiplication works, which I would argue the traditional way, for all its merits, does not do. The traditional way is just rote learning, and as long as you know that 3 times 2 is 6, and 3 times 1 is 3, and 3 times 3 is 9, and you can do the whole algorithm, then you arrive at the correct answer. But I would argue you don't really understand why the answer is what it is. It just is what it is. So again, this is not something you're going to be using like on the job. When you apply to a job with frustrated parent, he's not going to be expecting you to calculate, voltages or something using this weird table. But again, going back to the learning standards, this hits the place value thing, understanding that digits in a 4-digit number represent amounts of thousands, hundreds, tens, and ones. It also addresses 4B, read and write 4-digit numbers using base 10 numerals, number names, and expanded form. Like, what part of this do you object to as some kind of hippy-dippy liberal Marxist nonsense? Like, this is just very core, basic, hard-nosed mathematical learning. I'm pretty sure expanded form and base 10 are pretty foundational to learning your arithmetic. Also, the note here is really enlightening. It says fluency with procedures means students are accurate, efficient, flexible, and know when and how to use them appropriately. Developing fluency requires understanding why and how a procedure works. Let me say that again. Developing fluency requires understanding why and how a procedure works. Understanding makes learning procedures easier, less susceptible to common errors, less prone to forgetting, and easier to apply in new situations. In other words, if you understand how and why math works the way it does, you will be better at math. You will be less prone to mistakes, and you will have better mastery of it. It's not saying that you always have to do it this highly visual and deconstructed way for very simple arithmetic operations, but if you do it this way and you gain that understanding, then you're going to be less likely to make mistakes doing it the traditional way, and you're going to have the flexible, open-minded thinking that higher level operations require. And I'm sure you might be saying to yourself, okay, point taken, that's all fine and good, but there is a time and there is a place for rote learning in mathematics, such as learning your times tables. And you know what? I totally agree. I absolutely agree with you. Like, if only students still learned things like their times tables by rote memory. Oh, except they do. Standard 7b, know from memory all products of two one-digit numbers. Yes, students still painstakingly memorize their times tables, as they should. You should not have to work out with pencil and paper that 8 times 5 is 40. It's something you should just know. And you shouldn't even be thinking about, like, why does 8 times 5 equal 40? After a while, it doesn't matter. It's such a simple fact that you should just know it. Not saying that you couldn't use a number line or even some kind of weird place value table to figure out basic arithmetic. But yes, you're right. There are some things that should be learned by rote. But just the fact that other strategies and other methods of doing math exist does not mean that teachers are stupid and that Common Core, quote unquote, is some kind of idiotic way of teaching math. By the way, it's not just math. Again, I would challenge anyone who has a problem with Common Core to explain to me what it is, and if you can, I'll give you $1. So, in conclusion, neither of these ways of doing math is wrong or stupid. It's just different, and it's a way of visualizing and conceptualizing operations. And I reiterate that both of the parents who posted these things are kind of stupid. Thanks for attending my TED Talk. Goodbye.